What's going on, guys? If you followed the last video, you should have a script that generates a path between your enemy and your player. If you didn't follow the last video, you can actually download the script in the description of the video for free. Basically, today, what we want to do is, first of all, it doesn't chase the player around. So this path doesn't update ever. It only generates once in the start method. And then it doesn't update. And then we also want the enemy to actually go down the path after the player. If we have time, we might have the enemy be able to collide with the player and do damage to his health. If you guys are enjoying the series so far, make sure you like the video and subscribe to the channel. And yeah. Okay, so the first thing that I noticed is that in our enemy script here, if we change the distance to 1, so the distance is like the distance between the points that are getting drawn. If we change it to 1, it doesn't work anymore. So you can see that no points get drawn at all when we change the distance to 1. And this is because the raycast doesn't have a layer. So the raycast is actually hitting the enemy itself. It should only be hitting obstacles and walls, right? So we need to block off the layer for everything except for the enemy. We need to put the enemy on its own layer. So let's click on the enemy here, and then on the right side where it says layer, change the drop down, click add layer, and then in user layer 3, it's empty. We're just gonna put enemy here and create our own custom layer. And then we need to click on the enemy and actually drag like in the drop down, change it to enemy, and then we'll save it. And then, oh, I have to get out of play mode, hang on. And then change it to enemy. And then after we change this to enemy, we can use the same layer mask type deal that we did here to do everything except for the enemy, right? So we did everything except for the floor for this sphere cast. We can actually do this for the raycast as well. So right up here, we're just going to create a layer mask, and we're going to call this enemy layer mask. And then it's going to be everything except for enemy. So it only hits things that are not the enemy, because we don't want the enemy to be hit by it. So we can put a comma after distance, and then we can put the layer mask there. This will prevent this from hitting. And then we can also put the points onto this as well. So these points that are getting generated, we'll put them on the enemy layer for right now. And that will prevent them from being up. They don't have colliders anyway, so they shouldn't be getting hit because the raycast hits colliders. So, but let's just run this and see. Oh, the overlap sphere. Duh. Oh my God. Okay, so it's not actually this is not the problem. So we also need this to not hit the enemy himself. We're casting a ray to see if it's going to hit something or whatever, right? And then if it doesn't hit anything, then we're doing an overlap sphere at the destination position to see if it's big enough. This should be the lossy scale of, instead of it being the point, it should actually be the enemy that we're attached to, because we want there to be enough space for the enemy to actually physically go there. And if it's only as big as the point, which is actually smaller than the enemy, then it won't be big enough, right? And then we need this layer mask to be the floor and the enemy. I don't know how to do that, so I'm just going to go into ChatGPT and see if how to make a layer mask of everything except for floor and enemy. Unity. There we go. Okay, so we just need to put this like this is like the OR symbol, right? So we're going to be using this for floor and enemy. Yeah, we want this to be everything except for the floor and the enemy. So let's actually change this at the top here. So we can set this one to layer mask, and then we can actually just put this whole thing up here, because we only need to declare this one time. The layer mask is actually the same for both of them. So then we can just drop this in here. So we'll only have the one layer mask, and we'll just use it in both of them. This should fix the problem. Let's run it again. Okay, so now we're running into this problem, and this is because it's not within the distance, but it can't draw a point that's closer because the overlap sphere blocks it from drawing a point that's closer. So it actually is drawing 250 points, and it's lagging the game as well. So if you look on the right here, you can see all the points that are being drawn because we've made this a public variable, right? And if we go near the bottom, you can see that most of these are like the same, because it's just trying to find a direction that it can go, and it can't go towards the player. So when it gets into range of the player, we need to stop drawing, right? What we're going to do here is we're doing this overlap sphere at the location where we think it's acceptable to draw the point, right? And if the hit objects count is 0, then it's going to instantiate the point. But if the hit object isn't 0, we need to go through each of the objects. So each collider in the hit objects, and if the collider.transform.name is equal to stickman wizard, or whatever your character is named, maybe you're not using the same one as me. If it is, then we just need to return so that it doesn't draw any more points, because this will the overlap sphere will hit the player, right? And when it does, then it can stop drawing, because if it draws 250 points, it's going to lag your game. So let's just see if this works now. Okay, and it looks like it still has the problem, and I'm going to show you why it still has the problem. So when we're looking at this, we're doing a raycast from the current point, which is like getting near the, let me open Paint and show you. So this is the corner of the room. This is the player, and this is the point, right? This is the point that we're going from. So the distance from the point to the player, this is only 1 because we have that set as a variable, right? But the overlap sphere from this suggested point is the size of the enemy, which is like 15 or something, right? So it's like this. So the overlap sphere is hitting the player, which is why it keeps going. But I accidentally, so this is the overlap sphere code. So it's running an overlap sphere at the suggested point. And if it hits something, then it draws the, if it doesn't hit anything, sorry, it draws the point. Otherwise, it just continues. So the reason this doesn't work is because I wrote Stickman Wizard here, but my character's name is Stick Wizard Tutorial, not Stickman Wizard. So the reason that none of this is working is because I need to write Stick Wizard Tutorial here and not Stickman Wizard. Okay, so let's run this again and see if it works this time. Okay, so now it's working perfectly. So we've done something else kind of bad, and that was adding, so when we're creating this list of path, this should be a list of the actual points themselves that get added to the game. So we need to change this to a list of game objects. And the reason being is that when we redraw the path, we need to delete the path that's already there, because if the path is already there, then there's going to be millions of dots that just get added, and then eventually your game is probably going to crash, right? So instead of adding the point, like the location of the point to it, we need to add the thing that we're instantiating. So right below this, we'll just add the path while we're instantiating it. So that way it can be created and added to the list of points at the same time. And then instead of this taking in a vector 3, it needs to be a game object. So then that works again, but then it's gonna, oh, because it was taking that, right? Well, it could take itself as a game object. So just type in game object here. Okay, and then this current point needs to be the current point.transform.position for all of these. And we need to do that everywhere where it's like red and underlined. Yeah, so now we have the list of points or whatever, right? So when we call draw path, we want to invoke this repeating. So instead of just doing this one time, we want to do this every certain interval of time. We should make that a variable up here. So public float rebuild time. And we're just going to make it every 5 seconds for right now. In the future build, obviously, it needs to be less than 5 seconds because it has to update so that your character will actually chase the player around. It can't just be chasing, like if it takes 5 seconds to update, the path will be outdated and the enemy will never really catch up to the player unless you stand still for 5 seconds. So what we want to do is type in invoke repeating, and then we're going to type in name of draw path, comma. This is the time is 0, 0, and then the repeat rate is going to be rebuild time. So every 5 seconds, it will run this method for the entire game, right? Because we just want to have this, it has to regenerate in order for the path to stay up to date. And then in this method, we need to clear this path every single time we do this. So we can just do, we have to destroy all the objects first. So for each game object go in path, we can just, you don't think you can destroy game objects like this. We need to actually go through it for int I is 0, I is less than equal to path dot count plus I path at I. So game object dot destroy path at I. And then when we're just done destroying all of the game objects that are in the path, then we need to do path.clear. This will remove all of them from the list. You have to destroy them. It's really important. If you don't destroy them, then they'll all be there. You could also put them all into one transform and then destroy the transform, which will destroy them. We're not going to do that right now, but let's just see if this is working. So every 5 seconds, it should clear the path and then draw another path. Right, so if we move around, it should actually update the path to match our character. So let's see if this is working. Hang on. Okay, so we're in the game right now. There's, oh, index was at a range. Okay, hang on. Oh, it should be less than path.count because it's 0 based, right? So if path.count is greater than 0, we only want to do this if the path actually has things. So we'll check if the path count is greater than 0 before we do this. Let's try it again. Okay, 5 is like a really absurdly long time, but you can see that it's updating every 5 seconds. So this should be really every like couple of seconds, right? Okay, so I changed a couple of things to make this work better, right? So I changed the rebuild time to 0.3 seconds so that because it needs to rebuild faster, otherwise he won't keep his path updated and he won't actually go correctly. So when he gets to this last point, like he's going to be moving along this trail, right? And when he gets to this last point, he's going to use the player as the last point, right? So like when he gets close enough, he's just going to go towards the player. The player is kind of like the last point. So I've also changed the distance to 3. It doesn't really need to be 1. 1 is like it's more detailed, but it doesn't need to be that much. And I also needed to reset the point limit in between times that the path gets drawn, because if you remember, we set the point limit to 250, and if it goes to like if we actually get to 250 because it's constantly counting up, then he'll just stop pathing altogether, right? So each time you draw the path, you have to reset this. And I also changed it so that the path, like the list of paths, is it's not public anymore because game objects don't have any details in like the drop down or whatever. So you don't actually need to see this in the inspector. And if there's up to 250 points, like listed in the inspector, it's adding to the performance for no reason. Okay, so now we need to add a rigid body onto the enemy, right? So click add component on the right here and just type in rigid body and add a rigid body. You can leave the default settings for now. We might need to freeze some things like when we actually have a character, we don't want him to rotate automatically. So like we might freeze the rotation if it's an actual character, but because we're using a circle right now and this video is just for getting this blob to chase the player, there's going to be more parts to this video where we actually add an enemy with animations, and there's different ways the enemy can move, right? So like if you just have him moving towards the player at the same speed, he doesn't speed up, he doesn't slow down, he just goes like at the exact same speed the entire time towards the player, that's going to be boring, right? So we're going to have like a lot of different movement paths and patterns or whatever, and you're going to want to stick around for that in the future videos. But in this video, we're just making him go to the player. So we need to add a rigid body, and then we're going to set up the code for this. Okay, so now I'm going to show you how we set up the movement for this, right? So we have a start method where we're getting the rigid body that we added to the enemy just now, right? I set the rigid body on the enemy to freeze the position on the y-axis. That way he won't go up when he hits the enemy. So if he hits the enemy, right, they both have box or colliders attached to them, and because he's a sphere collider, when he's trying to push into the player is locked on the y-axis. He's not going anywhere, so the enemy will go off flying off into outer space. So to prevent that from happening, you can lock the position on the y-axis. It's actually required. So we're getting the rigid body in the start method, right? And then in the before the update method, we're declaring this variable for where we're moving towards, and we're setting it to 0, which is like the origin of like the game. If the path count is, so if there's items in the list of the path count, right? If there's items in the path, then we're going to set the move towards value to be the first item, like the first point in our path list. So we're taking the first point minus the enemy's position to get the direction, right? And then we're setting the velocity to be that direction, and you have to use normalize and then multiply it by the speed. And then we're checking the distance to the target. So we don't want to check if he's actually made it to the target, because it's rare that they'll actually be directly on top of each other. So like if you're moving towards a position, it might take him a minute to actually resolve and get exactly on that position. So to prevent it from taking a long time, we're just checking if the distance is less than 0.1. This could even be like a little bit more. So if it's less than 0.3, then we're going to move on to the next. We're going to start going to the next point. So before he even gets to the first point, it's going to check the distance. And if the distance is less than 0.3, then he's just going to start going to the next point right away, right? So when we get to around the point that we're moving to, like the first point in the list, we're going to destroy that object. That point can get deleted because we don't need it anymore, right? We're not going to delete it immediately because we need to remove it from the list, like the path list. If you've already destroyed it, you can't remove it from the list, but you do have to remove it from the list, because if you leave it there, there'll be a null object in your list, and when it tries to go to it, it'll give you errors or whatever, right? So if there's nothing in the list, like if there's nothing in the path, there's no more points because your enemy is close enough to the player, then we're going to set the move towards to be the player, right? So we're going to use the player's position instead of one of the points, and we're just going to set the velocity to the same. I also added a speed variable. This is how fast your enemy will move towards the player, right? So I've set this to 15. This is really slow, but we're going to turn it up while I'm demonstrating it. So let me unpause this. And oh, sorry, I changed the code while it was running. Let me just run it again. You can't change the code while it's running. Yeah, so you can see that like there's the enemy, he's chasing the player. And if you go directly across, he'll kind of go back and forth. And you know, enemies do this in like a lot of games, including the Binding of Isaac. If you try to fight a zombie in the Binding of Isaac and you go directly across an object, this is exactly what happens, right? So this is the exact kind of, I don't know if it's the same algorithm that they're using, but it's very close, I think. And this is very robust. Like when you're using the nav mesh agent, it feels like they speed up and slow down completely at random. And getting it to work perfectly and having it not try to cut the corner and to actually go all the way around it just doesn't work the same way as this. This just feels a lot better and a lot smoother. So let's turn up the speed a little bit. So let me just get away from the enemy for a sec, and we'll just actually pause this. And we're just going to turn up the enemy speed to like 30. And yeah, so you can see that's like a little bit faster. And this is just really, really good. Just click stats for a second, make sure I'm not like tanking my FPS. Yeah, so you see I have 300 FPS still, so we're still really good on this. So let's go back. So when he hits the player, nothing happens, right? So we need to make it so it damages our player when we get hit by him. Okay, so what we need to do is when he collides with the player, he should do damage to the player. So let's type in on collision enter. And what we're going to do is if the collision.collider dot name is equal to stick wizard tutorial, or we could make a tag for this instead. We should probably have like a player tag, that way we can rename our player, and we can make it like, let's say we have like I don't know, let's just leave it like this for right now, but you could make a tag. That's probably a more appropriate thing to do. But what we want to do is we could just type in hard script dot damage or take damage and then 1, right? So we already made a take damage script that was in a previous video. So if you've been following the series, you should already have this. But in our heart script, we made this take damage method static. So we don't have to do anything else for this. We can just take damage. And because this already makes the player invincible, we don't have to limit this to, because usually you would have to use like a Boolean value or a state or something to prevent the player from taking multiple damage. But in this case, we don't have to do that because we're setting our player to invincible in the take damage method. Now we did a whole video on taking damage. So if you didn't watch that one, obviously you'll have to make your own take damage method or whatever you want to do, right? So if we've set this up correctly, we should be able to get hit by the enemy now. Okay, so let's see. Yeah, so you see, like, when he catches up to us and hits us, it does damage. Now, we also need to make our character move backwards. Like, when he gets hit by the enemy, he should get pushed backwards. Like, it shouldn't just, like... Yeah, this is feeling really good. But yeah, he should get pushed backwards, and there should be some type of like animation, and he should go flashing and that kind of stuff. We're going to make a whole video on making him flash and how he's going to take damage and what he'll look like for that. So like the heart script is obviously done, but there should be an animation and like some type of pushback. So all right, guys, thank you so much for making it to the end of the video. It really means a lot to me. If you enjoyed the video, make sure you like the video and subscribe to the channel. In the next video, we're probably going to make it so that the enemy is going to be a real model. So there's going to be like an actual enemy, like a character here instead of like a red dot, and it's going to be animated, and it's going to be probably looking towards the points as it's moving. And then we're also going to probably use sign to make it so that he goes faster and slower and faster. So he's not always going to be going the same speed. At a certain interval, he'll start going faster and then he'll go slower. Like it's like he's using energy, I guess. So like he'll use his energy and then he'll go slower while he's like trying to recover. That will make him harder to dodge for the player, because like right now, obviously we don't really have any obstacles in the room or anything to prevent you from being able to get away from him. We also need to make him be able to take damage and that kind of stuff, but the next video is probably just going to be dedicated to more movement stuff. Like I said, I hope you guys enjoyed the video. The entire script is available in the description of the video, so you can download it, and I hope I'll see you in the next one.